doing composition with functions, what you're doing is you're taking the function and you're plugging it into another function. So just like what we did with the numbers, you're still working inside out, but you're taking the function that's on the inside and you're plugging it into the variable spot of the function on the outside. So, for example, if we have k of f of x is on the inside. So our f of x function right now is this one. So I'm going to take this function, and that function is going to go into the k function. So here's our k function. So what I mean by that is my k function is 12 minus 3x. But instead of x, I'm going to leave it blank. So 12 minus 3 blank. And inside that blank, I'm putting in the f of x function. So I'm putting in 5x squared minus 8x. And then we're just going to distribute, and we end up with 12 minus 15x squared plus 24x. And then we want to find the domain of our final answer. So our final function is a quadratic, so the domain is going to be all real numbers. Okay, so if we look at the next one, g of h of x. So we're going to take the h function, and we're going to plug it into the g function. So we're going to write the g function. So it's going to be 4 over 5 blank. And in that blank, I'm putting in my h function. So I'm putting in radical 7x. So when I go to solve this, I have 4 over 5 radical 7x, which I have to rationalize. So radical 7x over radical 7x. So I get 4 radical 7x over square root of 7x times square root of 7x is just 7x. So 7x times 5 is 35x. And then we need to find our domain. So again, overall this is irrational, but we want to focus on the radical part of this. So the domain here would be x is greater than 0. And if you're not sure how we got that, you can consult the other videos where we did the same thing. Okay, so now we want to do h of f of x. So we're going to write the h function, which is square root of 7x, and we're going to leave a blank. And in that blank, we're putting in the f of x function, which is 5x squared minus 8x. So 5x squared minus 8x. So we're going to distribute this, and we have the square root of 35x squared minus 56x. So that would be our final answer. And then we have to find the domain of this. So to find the domain, since it's a square root function, we want to take what's under the radical and set it greater than or equal to 0. So if I take 35x squared minus 56x, and I make it greater than or equal to 0, I have to first factor this. So I can take out the x, and I have 35x minus 56 is greater than or equal to 0. So if I solve this gives me x equals 0. And this, if I solve, gives me x equals 56 over 35, which reduces to 8 over 5. So in order to figure out what symbols go with what, if I were to graph 35x squared minus 56x, that would be a parabola that has zeros of 0 and 8/5. This is 8/5 over here, and this is 0. So it looks like this. So I care about where it's greater than or equal to 0. So I'm going to focus on this piece and on this piece. So that would be, the domain has to be x is less than or equal to 0. That's the left side. And also x is greater than or equal to 8/5 because that's the right side. Okay, and then in this last one, we have g of f of x. So we take the g function, which is 4 over 5x, and we leave it blank. And we're going to plug in the f function. So we're plugging in 5x squared minus 8x. And then we're going to distribute. So we end up with 4 over 25x squared minus 40x. So that's going to be our final function. And then we want to take, since this is a rational function, we want to take the denominator and set it equal to 0 to find our restrictions. So if we set 25x squared minus 40x equal to 0, we could take out a 5x, and we're left with 5x minus 8. So if we set each one to 0, 5x, if we set that to 0, we get 0. And if we set 5x minus 8 to 0, we get 8x. So our domain would be all real numbers, except x cannot equal 0 or 8. Okay, so if we try a couple more of these, okay, same process. So f of k of x, we're going to take the f function. So again, let's just color coordinate these. I don't remember if these were the right colors from before, but same idea. Okay, so f of k of x. So I'm going to take the f function, 5 blank squared minus 8 blank, and we're going to plug in the k function. So we're plugging in 12 minus 3x and 12 minus 3x. Okay, so here you have to FOIL the 12 minus 3x and the 12 minus 3x. So this would be like 5 times, if you FOIL 12 minus 3x, you end up with 144 minus 72x plus 9x squared. And then you would distribute this, so that's negative 96 plus 24x. Okay, we want to distribute the 5 to everything, and then combine like terms. Okay, so just for time purposes, we end up with 45x squared minus 336 x plus 624. Okay, this is a quadratic. So since it's a quadratic, our domain is all real numbers. Okay, f of h of x. So we're going to have 5 blank squared minus 8 blank. And we're plugging in the h function. So we're going to plug in radical 7x here. Oops, and radical 7x here. So I'm going to square radical 7x, and I'm going to get 7x. So I have 5 times 7x, so that's going to be 35x minus 8 radical 7x. So this is going to be a radical function, since there's a radical in it. So for those, I set the radicand to be greater than or equal to 0. So the domain is going to be x is greater than or equal to 0. And the next one, k of h of x. So we're going to write k, 12 minus 3 blank. And we're going to put in the h of x, which is radical 7x. So we end up with 12 minus 3 radical 7x. So again, this is a radical function, so the domain is going to be x is greater than or equal to 0. And for the last one, k of g of x, we're going to take the k function, which is 12 minus 3 blank, and we're going to plug in the g function, which is 4 over 5x. So we have 12 minus 12 over 5x. So remember, that 3 is like 3 over 1. So we can't subtract these the way it is. We need a common denominator. So right now the 12 has a 1. So I'm going to multiply this by 5x on the bottom and on the top. So now that they have the same bottom, I can smush the top. So I have 60x minus 12 over 5x. That's my final answer. This is a rational function, so I take it's in the denominator and I set it to 0, and that's my restriction. So my domain is going to be all real numbers, except x cannot equal 0.